Hey guys, so today we're going to be looking at a program around palindromes and how basically a program to check if a string is a palindrome or not. So here we go. Okay, so today we're going to be looking at a palindrome program. So here we're just going to be entering basically any string and then checking if it's a palindrome or not. So palindrome is basically if you don't know what it is, it's like when something is read the same way from left to right or right to left. Like if we take the name Hannah, that's a palindrome because it's like H-A-N-N-A-H. And then the same thing, H-A-N-N-A-H, if you read it backwards. Or like 1-2-2-1 or something, you get the point. So here we have A defined as an empty string, which is basically where I'm going to be filling in like the palindrome, for example, Hannah. And then B is also an empty string. Then if A is entered as an empty string, then just print it as invalid. So we don't put any effort onto that if you've entered nothing. Then here we've done this range thing before. So this is so that we basically enter it character by character backwards into B. So using this we do for I in range, then length of A, which in this case is 3, 4, 5, 6, 6, minus 1, so 5. Then 5 to minus 1. And then we have minus 1, like it's stepping back by minus 1. So what it's going to do is going to start from the last character over here, and then it's going to build on. So if I do like a print B, and yeah, so now, okay, now if I run it, then here you see that it starts at H, then H-A, H-A-N, and builds Hannah. And in the end, because A is equal to B, because from left to right, or right to left is the same thing, then it is a palindrome. If we take something a bit different, if we take Hannah, if I just take away the last character, now it's no longer a palindrome. So now it's starting, so now B, the right to left one, that's basically A, then A-N, A-N-N, Anna, and then in the end is Anna instead, just not a palindrome. Now if we test it out with numbers instead, so then again the same thing happens, so it's 1, 2, because it's a string, so I just defined it as a string. So you can essentially enter anything you want, I can just enter the most random characters on my keyboard. And okay, not a quote, but if I enter a hyphen and then a full stop, then yeah, so it's not a palindrome. So you can enter essentially anything you want, and all B does is that it reads it backwards from right to left instead and flips it over. And so what I'm doing here is that this part is pretty simple. It's if A is empty, then it's invalid. So if I just run it like this, then it's invalid, and then we're just exiting. We're not going any further in the program. That's what exit does. Because if I take away the exit, then it's going to be another problem. It's going to go invalid in palindrome because A is equal to B in this case. So it's going to end up printing palindrome, which is why we need the exit over here. Then for loop, and then here, B is equal to B plus A of I, because I is a number, and then A is the string. So then B, whatever B is at that moment, in the first round B is empty. So empty plus, if I enter Hannah here again, good example. So then I is basically going to be minus 1. So then it's basically that B is equal to empty plus A of minus 1, which is H. So if we run this, that's how we're getting this H over here. Then next time, when it runs, B is already equal to H, the string B already has an H. And then it has H, so H plus, and then A of I. In this case, I is minus 2, so then it's A. So then it gets added H plus A, so then you have a string, because that's how the string is added. So then it becomes HA. And that's how it builds the same thing but inverted. And then by the end of it, if A is equal to B, then it's a palindrome. So if left to right is equal to right to left, it's a palindrome. And if A is not equal to B, then it's not a palindrome.